Whether you're staring at your first synthesizer for hours on end, not sure where to start, and not sure what the knobs do, or maybe you're tired of using factory presets and you want to create your own, but you're not able to harness the power of your synth. Either way, you're not alone if you feel overwhelmed by synthesis. In this series, we'll explore various synthesizer concepts, from how sound is generated to twisting those knobs and creating a sound that you can use in your music. This is a Korg NTS-1. We'll use this as our starting point to discuss synthesis. Understanding this device gives us a foundation upon which we can add more complexity and features. This device features one digital oscillator, a multi-mode filter, one envelope, LFOs, and effects. Don't worry if this sounds like a foreign language. We'll define each of these terms while showing examples throughout this series. An oscillator is an electronic device that generates sound. Electrical current goes into an oscillator and is converted into a signal of sound. Think of a guitar string. When it's plucked, the string vibrates and it generates sound. A sound wave is emitted from the instrument into the air and we can hear it. Each time a string vibrates back and forth, that is a cycle or a wave. The speed at which it vibrates is its frequency. This is oscillation. Oscillators can be controlled by various parameters, including frequency and waveform. Playing a note on a synth produces a waveform at a corresponding frequency. Frequency is referenced in hertz. The audible range of human hearing is typically between 20 Hz and 20,000 Hz. Playing a different note changes the frequency of the oscillator and therefore the pitch of sound we hear. We can modify the tonal characteristic or timbre of the oscillator by changing its waveform and shape. Common waveforms are sawtooth, triangle, square, pulse, and sine. In addition to being able to change between these, we can also change the shape of each. By changing these parameters, we are changing the harmonic content of the waveform, and this is one of the core principles of synthesis. Now, there are a variety of different oscillator types, designs, and ways in which they can be controlled, each with its own benefits and characteristics. For example, this Moog Sub 37 is an analog synth with two oscillators and a sub-oscillator. Even if we only use one of these oscillators, it will sound different than other synths with the same waveform because of its design and circuitry. This synth also features an octave switch to change the pitch range of the oscillator. Fun fact, pitch range is referenced in feet, a throwback to pipe organs where the length of pipes and pitch are related. Since we're here, we can turn on the second oscillator, change its shape, and see how rich and complex the harmonics can be with multiple oscillators. Speaking of different oscillator types, some synths allow you to load an audio sample into the oscillator, which is called sample-based synthesis. Of course, an audio sample contains a wave shape, but the significance of this is that you're not limited to the basic waveforms of a typical oscillator. For example, on this Teenage Engineering OP1 field, one of its synth engines can load a sample to generate sound. The start, end, and loop points of a sample can be altered, which affects how the sound is played back. Even from the same sample, we can generate a variety of different sounds. Not to be confused with sample-based synthesis, but there's also wavetable synthesis. This is where a series of single-cycle waveforms are loaded into the oscillator, and sound is generated by varying or modulating the selected waveform in the wavetable. Here's a quick example on the Synthstrom Deluge. Okay, long story longer, there's also FM synthesis, where oscillators are modulated, and there's carriers which can have their own oscillators, and things get pretty complicated. Too complex for this video, but let's see a quick example to get a sense of it. This is just the tip of the iceberg in terms of different oscillator types and how to manipulate them. Each synth's design is a bit different, and it's one of the reasons you see collectors with rooms full of synths. So don't be afraid to explore and dive into a world of oscillators and synthesizers. Hey, before you go, consider subscribing if you learned something, and check out the description for more information. Thanks!